Hello everyone, and thank you for watching this video. My name is Dionysia and I'm a PhD candidate at the University of Ottawa. The paper I'm presenting here is based on work I've been doing on my PhD thesis, which focuses on political aspects of mathematics in the context of undergraduate mathematics education. To this end, I've collected and been analyzing data from 2 undergraduate mathematics courses in Ontario. In this presentation, I'm going to share with you a short introduction from an Introduction to Proofs course, which is intended for first-year students. I'm going to suggest that there are 2 discourses manifesting themselves in this interaction, one being mathematics as a social practice, mathematics being conceptualized as a social practice, and the other conceptualizes mathematics as the product of an established discipline of what mathematicians do, basically. I'm going to propose that the 2 discourses are an antagonistic relationship, and then I'll end the presentation suggesting that these 2 discourses do not only exist in my data, but more generally in the field of mathematics education, and can be viewed in the relationship, can be viewed as antagonistic, as an antagonistic relationship. So this is the short introduction, which is about a visual proof. So the theorem that is being proved here is what you see at the bottom left of your screen. And because there's a lot of jargon there, basically the idea of this proof is that if we have pairs of numbers like -5, 3, 0, 0, 2, 6, pairs of numbers where both numbers are integers, then all these numbers, all these pairs, can be written in a sequence which has a start and no end. So this is what this visual proof proves, that such a sequence exists, and we can see it through the spiral. So it starts with 0, 0, it goes on with 1, 0, it continues with 1, 1, and so on as a spiral. So the interaction that follows the presentation of this proof by the professor in the class is about whether this is considered a formal proof. And I'm going to ask you to pause the video to read the interaction yourselves. And then I'm going to talk a little bit more about it. So what I'm suggesting is that there are 2 discourses manifesting in this interaction. One discourse, one of them suggests that mathematics is a social practice. The other discourse suggests that mathematics is the product of an established discipline. So starting with the first discourse, mathematics as a social practice. What I mean by this is that mathematics is done in and through interactions between people. So we see this discourse manifesting in the interaction, first by the very fact that the visual proof is presented in order to make the idea of the argument clear and communicable. So not every first-year course would include a visual proof. We also see the discourse of mathematics as a social practice in the emphasis which is placed on people having a shared understanding of the argument. So if you focus your attention on the first purple sentence, the professor asks the student if he asked 2 people to find the 10th element of the sequence, whether they would come up with the same 10th element. So the idea of the shared understanding is important here. Third, we also see the discourse of mathematics as a social practice in the discursive construction of a good proof as one which facilitates understanding. And this is quite clear in the last part of the interaction, where the professor says that they typically avoid presenting the complete formal proof of the theorem because it hides what's actually going on. So a good proof is one that shows what's going on. And one last comment that I wish to make here is that this discourse of mathematics as a social practice does not only manifest itself in this interaction, but more generally, the professor makes a lot of effort to conceptualize mathematics as a social practice in this class. However, we also see another discourse, a discourse which conceptualizes mathematics as the product of mathematicians' work. So here we see this discourse in the clarity with which a visual proof does not quite qualify as a formal proof, and maybe not even as a proof. So it doesn't qualify as a proof, as a formal proof, very clearly by what the professor says in the purple part here. But also, if you noticed earlier when we had the picture of the proof, the word proof was in quotation marks, suggesting that maybe it's not exactly proof. We also see that what constitutes a proof and a formal proof are created outside the walls of the classroom, independently of the interactions between the professor and the students. So in fact, the student poses their question by asking, is this considered a formal proof, using passive voice? The standards now of what constitutes a proof and what constitutes a formal proof are the result of the practices and norms of the mathematical community according to this discourse. In turn, these practices and norms, they are reflected in the academic requirements which are set for the students of the course. What I'm suggesting is that the two discourses are in an antagonistic relationship. I'm borrowing the term antagonism by Laclau and Mouffe, who have done work in discourse analysis. What they suggest is that meaning is never fixed. This means that something like mathematics, for example, its meaning is not fixed. It can change any time. So in this conceptualization, what discourses are is partial fixations of meaning, but they're partial. And the main idea here is that different discourses, like the two discourses that we talked about, struggle to fix the meaning of privileged points called floating signifiers. So proof or formal proof could be floating signifiers here. And we notice that I'm using the term antagonism, but it's not the teacher and the student who are in antagonism. It's actually the discourses which are in antagonism. And we notice that the two discourses can also be enunciated, and they are, in this case, enunciated by the same person. So the two discourses which are in antagonism, they're both enunciated by the professor. So the two discourses struggle to fix the meaning of privileged points, which are called floating signifiers. Proof is a floating signifier here from this perspective. On the one hand, the discourse of mathematics as a social practice attempts to conceptualize proofs as including well-articulated visual arguments. On the other hand, the discourse of mathematics as an established practice does not focus on understanding, but instead attempts to conceptualize proofs as a formal construct in which each proposition follows from the previous one. Similarly with formal proofs, we see that the discourse of mathematics as a social activity tries to fix the meaning of the formality of a proof in terms of the existence of a common understanding. Yet, this does not result in the recognition of the proof as formal. There seems to be something more about the formality of a proof, which the discourse of mathematics as a social practice cannot quite challenge. This more is created by the discourse of mathematics as an established product, which is at a privileged or hegemonic position for defining what is formal. So the whole idea here is that there is no a priori meaning of these concepts. Instead, their meaning is constantly negotiated and produced through antagonisms between discourses, which are historically, culturally, and politically situated. So we saw how the two discourses, mathematics as a product and as a social activity, how they're evident in the interaction. What I'm suggesting is that they are also evident in mathematics education more generally. On the one hand, we have discourses which talk about mathematics and what mathematicians do. And on the other hand, we have discourses which talk about mathematics as the product of social activity, as what students do in the class, as what people do at their jobs, and so on. Often, the two discourses are presented through a narrative of progress. So we have the old mathematics education goes the narrative, used to focus on what mathematicians do, but now we focus more on what students do when they work with each other. My suggestion is that this relation could be understood as an antagonistic one. So the discourse of mathematics as a social practice operates within institutions in which students are expected to master a specific material, which is often described in the curriculum. Hence, I'm suggesting it falls very short in terms of challenging the existence of a knowledge which will not change regardless of what the people thinking about it think or do, as suggests the discourse of mathematics as a product. So by thinking of this relationship as an antagonistic one, we can think about how both discourses, we can focus on how both discourses are simultaneously present and how the results or their products of them being co-present and antagonizing each other, how they produce things, how we have the production of a specific mathematical knowing, but also how we have the production of ideologies about mathematics and beyond. So this was it. Thank you very much for watching.